Brothers Wisp podcast, insert number here, not too sure what it is. So, you know me, I'm Tom, and this is Henning Brouwer.
Hello.
Peter Hessler.
Hello.
And Rick, can't pronounce his surname. Floater, thanks very much. Basically, as you know, I'm a BSD fanboy, OpenBSD in particular, and these lads do an awful lot of work. So I'm here basically talking to the guys at BSD Can, and I just wanted to kind of have a chat with them, and they said, yeah, no bother. And so we've had one or two beers together, only the one or two, and we've had good fun. So I was just going to say, can you each tell what you do in the project, what's your favourite aspect of it, and what do you use most in OpenBSD for your own operations?
Okay, I'm with OpenBSD for quite a long time now. It's 15 years actually. I've done a fair number of things, like probably the most well-known is PF, which of course I didn't do by myself. I was not even the one who started it, but I'm basically the main maintainer, if you want so, for more than 10 years, and it has basically been rewritten in that time. So it's kind of safe to say it's my baby today. I started OpenBGPD. In the last couple of years, other people were more active in OpenBGPD than I was, and that includes Peter. I wrote OpenNTPD. What else? Lots of stuff in the network stack. Like generally, I'm a networking person, so I'm all over the network stack in the kernel. Yeah, what do I like most on OpenBSD? I like the consistency. I like that it never lets me down. It's very predictable, no surprises. And I use it all over the place for our company infrastructure. So we are a hosting company running some, I don't know how many OpenBSD machines, 200-ish. And well, OpenBSD is so secure that I don't have to worry sitting here with having lots of services open to the internet. I can sit here, I can sleep properly without worrying about the security of my systems and without having to worry about them crashing actually, because they just work. And that's the bit I like most. It just works. It does work as advertised, period.
Cool. So the rest of you lads who are not running OpenBSD, just be afraid. Be very afraid.
So I'm Peter Hessler. I've been a developer with the project since 2008. I was originally a porter, just porting games over so people can play their favorite games. Eventually, I got conned into doing more and more work with the network infrastructure. Played a lot with OpenNTPD, with writing domains. And currently I'm doing quite a bit of work with OpenBGPD, so I'm currently one of the co-maintainers.
Yeah, I'm Ralf Flöter, I'm also from Germany. I wrote some stuff in OpenBSD, like a load balancer, relay, a web server, an SNMP daemon, which is a management protocol. What else? VPN, IKD, and some other things. Various. So I'm mostly interested in networking side and cloud-related stuff and so on. Yeah.
That's cool.
And I'm in the project for, I don't know, almost as long as Henning, like 12, 13 years about this. Yeah.
You came like 1 or 2 years after.
Yeah.
Like not very long after.
Cool. Does Henning use that to pull rank? Does he use that to pull rank? You know, I really this project longer. I'm
No.
joking.
No. Henning is just always bragging. That's natural, but we all do.
I believe the correct response to "I've been in the project longer" is "Okay, Grandpa," and your point is.
Exactly.
Yeah,
Exactly.
that's fine.
That's actually something I really like about the development community. When we argue about something or we discuss something, it's about the technical aspects.
Yeah.
It's not, I've been doing this longer than you or something like that.
Yeah.
Who has the better argument on the technical side? Period.
Yeah.
Please provide evidence. Yeah.
No, I suppose I'm using it in the networking stack. I've really started using our domains, and I'm really liking it. And we're kind of starting to go, oh, it does web servers too. So we're kind of playing around with that. But I've used it with PHP, so it's kind of slightly different to, let's say, the way the guys run the websites normally. And I suppose, have you any tips for people, like in terms of what's the best way of getting documentation on OpenBSD?
So really the best way is just read the man pages. We have put in a surprisingly large amount of effort into these, especially compared to other projects. If the man pages are wrong, that we consider that to be a bug. If the man pages are incomplete, we consider that to be a bug. So we do strive to make the man pages as complete as possible. So you can learn how to use OpenBSD without requiring external assets.
That's cool. So lads, when you're on top of a tower and you're trying to get a router working, you're like, oh, what's that command? You command the command, and you find the switches. And that was one of the mistakes I was doing, was when I was Googling OpenBSD, I was reading like papers that were maybe 5, 6 years old, and then like obviously, you know, it says, oh, this is not supported. You're like, oh crap. And then you do the math, and it's already supported.
And sometimes we add support for new things, yes.
Yeah. But additionally, there's the FAQ. It's on the webpage, which gives good introductions that I think it also mentions to read the man pages.
Yes,
Which is not really an FAQ.
It's a tutorial,
more like a handbook.
Yeah.
And then there are a number of actual books, the e-books or print books actually, like Relay and HTTPD Mastery. It's new. You can order it now.
Very good, yes.
Oh, that is actually a very good answer to the question, how do I get started? Grab a copy of Absolute OpenBSD.
Yes,
That's a very good book to get started.
Yeah.
Or the book of
PF.
PF,
That's a good book to get started with PF, but to get started with OpenBSD, grab Absolute OpenBSD.
Yeah, no, and it's like, for me, like the books provide the context that the man pages are very factual. They're like, this does this, and you're like, what's that? Read the book. So that's where that, or get a book, kind of more like. But I've been surprised at like how consistent and how when you configure it initially, it keeps running, save for external factor like lightning bolts and stuff like that. You know, some of you call it an act of God, which is okay. We call it static electricity, but we won't get into that. Anyway, sorry,
Sure.
so I'm trying to. So basically, like obviously the guys who do WISPs and stuff like that. What's the features that you're currently like really like that's exciting you in OpenBSD that's currently in active development? Like, I suppose.
I know. What I'm currently also working on, what I want to use and I love, it's like the virtualization. So I mean, that's something that's been out there in Linux and other systems for a long time. But now in OpenBSD we have our own implementation of running virtual machines on OpenBSD, so like other OpenBSDs on OpenBSD or Linux also. But the main difference is that we can design it in a way that we like, and we can design it in a secure way that others don't do yet. And I'm very excited about it, and it's just fun working on it.
And so, like, what sort of like security mitigations do you like? What's your favorite security mitigation that you use? Like, and what's like, I suppose. Like
Generally or in VMM?
Oh, generally, but like generally, like I know VMM obviously is, let's say, it's
What they're probably most well known for, which is one of the very, very basic techniques, is privilege separation. We always try to follow the principle of least privilege, as in whatever runs should have exactly the amount of privilege it needs, but no more. That also means if there's a bug in that component and it's exploitable for some reason, well, you end up as an unprivileged user, typically rooted into some empty directory. So you basically got nothing to play with, opposed to running everything in one big monolithic process as a root or another privileged user. If you exploit that and break out of the container, that's the wrong word here. But if you find something to exploit, you find yourself in the file system with lots of to play and root privileges in the worst case.
Yeah.
So that's
like
very important.
In the virtual machine example, each guest operating system is in their own process. Each one is running not as root. Each one is CH rooted and doesn't have direct access to networking, for example. So if you were to exploit this mechanism and escape to the host, you don't have root privileges. You can't run your attacks. You cannot send network traffic. You don't have access to the file system. And so this is protecting those things, and the privilege separation we've applied, we look at each component of these things and see if we can separate them out.
Yeah. But there's something that for me where it starts in OpenBSD, and that's not privilege separation and randomization and all these things that we do. I think the most fundamental part that dragged me into the project is the code quality. I look at the source code. We have this one huge repository of the source code, and most of the code looks clean and has the same consistent style. We have our coding style, and we follow it very strictly. And if somebody finds, oh, this white space there is wrong, and then you can change it. And I'm also using it at work. I didn't say what I work. We build firewalls. My company based on OpenBSD.
So what's the name of the company?
Estenera.
Okay, cool.
And here it's the same. I tell my team, like, okay, even in the internal code that we do, I want to see the same style, and I want to look at it, and everyone can use it, and you don't have to get in. Okay, what was this person? I don't know, smoking when they did this.
And
Consistency is a big point.
Yeah.
Also, all these security techniques we briefly mentioned, I think like they are super important.
Yes.
But they are really just, how to put this, an expression of the overall attitude. Like for us, the security of the operating system, each and every component we work on, is an integral part. It's an integral part of designing those components, and it's not an afterthought. It's not you write first features, work on, oh, how about security implementations? No, we think about security first.
Yeah.
We design it in.
Okay.
And that expresses itself in all these techniques like privilege separation, privilege revocation, or the randomization.
Cool. So let's say the BGPD design, let's say the privilege separation is similar to what's done in SNMPD, SNTPD,
Yes.
HTTP.
They even use the same framework.
Cool.
Yeah, so for many of those daemons, they're using the same framework, they're using the same basic design principles. It's like, oh, this talks to the network, this talks to other things on the network. So let's prevent it from having root, let's prevent it from having access to file system, let's prevent it from this thing, prevent it from that thing. And like the thing that processes the data from the network is a separate process. And it has its own set of rules and regulations, and we're using message passing to prevent any sort of influence on the other processes, and it's a very common aspect of our privilege separation design.
There's a term that we use, exploit mitigation techniques, and sometimes at least. And there's one thing is vulnerabilities are often about bugs, and then they get fixed, and or do we have these bugs? And people sometimes think, okay, you just have to try harder and write good code, but we all make mistakes. But many of these very famous exploits or vulnerabilities out there just didn't work in OpenBSD, like shell shock. With HTTPD, it's just not possible to run a shell that gets a password file from the system because it doesn't have access to the password file on the system. So even if we have a bug in there, it wouldn't work. And whatever, this Venom QEMU attack where you could escape from virtual machines and read stuff on the system and do bad things, the design of all virtualization doesn't allow that, and so on. So design and these mitigations are very important part. It doesn't mean that we're like 100% safe, but we try very hard to design it this way.
Actually, an important and very interesting point. So the first rule to secure software is to code properly. Like,
sure.
Yeah,
be
don't write
careful,
bugs.
be super careful with user input, verification all over the place, stuff like that. So usually we don't even have these bugs. Like in the entire lifetime of OpenBSD, we had 2 remotely exploitable bugs. For one of them, we are not even entirely certain whether it is remotely exploitable. We just labeled it so because it could be. The other was an SSH and affected everybody.
Yeah.
I think this is a pretty great track record for 20 years.
Yeah.
And this is without the mitigation techniques.
So
however, we don't stop there. We basically design countermeasures in case we screw up. So we assume we know we are not perfect.
Yeah.
And we don't fall for the illusion that our almost perfect code is good enough. We build in multiple layers of defense. So even if the topmost layer doesn't work, there's the next one.
Cool. And so like, like your track record over the past 20 years speaks for itself, so it's another kind of metric on the methodology that you've been using. So it's not just about coding, it's your process.
It's
and
mostly
your
attitude. I think that's the really important bit.
That's cool. And so, like, how can you describe the release cycle? How does it work? Like, so when, and how do we track the latest things that are happening?
So the release cycle is pretty simple. Essentially, our current, our so-called head branch, the main development tree, is effectively required to be release ready at any point in time. It is always ready for us to do a release. And as we get closer to a release, we tell, okay, so let's slow down, stop putting in risky things, start doing some more tests. People will intentionally, people are always putting current and head in their production systems. I personally, on one of our edge routers, run current almost once a month. And we have other machines on our network that we are putting on various versions of current to ensure that it's a high quality. We know the machines are having it and what the risk factors are, of course. But then, as we get to release, it is just simply, okay, we're calling it a day.
Jump in here
Yeah.
to strengthen your point, really. The fact that we keep current very usable over the entire release cycle is important because that allows us to run it. And that in turn means we don't do a big round of testing before release. Well, we do that, but since we are running current during the entire release cycle, we pretty much get continuous testing.
Yeah. Okay.
Now,
My laptop is current.
of
My
course,
workstation
mine.
at work is current,
Same here.
My one is release.
which is fine.
Sorry.
And I'll be fair.
But,
You'll
but,
get over that.
but does it mean that we did continuous development and integration deployment before it was cool, actually?
Oh, I'm getting a buzzword overflow again.
I could see that argument.
Sorry.
So now
If
to
you
be
want,
fair,
continuous
I
integration in the
do.
cloud on mainframes. Oh, sorry, that's IBM.
To be fair, a lot of my systems are running release or stable, and that's fine because we have a lot of machines. We have 40 racks, and I don't really want to upgrade every single machine every month. That's a lot of effort.
And you need a matching set of packages.
Yes, so I need a matching set of packages.
If you install a current machine and like 3 months later you need to add a package, but it's a production machine that you can't just reboot, well, either you have a package snapshot that matches that
Right.
older current, or well, you might get lucky and it still works, or you might not.
Yeah.
So that's the main reason for many production
Yes.
systems running.
Yeah.
So for,
running
let's say, the
release.
risk-averse user who's not necessarily going to contribute to the testing, so the release cycle you're saying is continuously usable, let's say the operating
Yes.
system bases,
Yeah.
the packages, the integration, there's occasional snapshots of packages made available, is that correct?
Pretty much
Yes.
daily for the fast
It's
architectures.
basically every 1 or 2 days. So they will occasionally get out of sync, and that's because we do library bumps and change version numbers when we need to, and we are not afraid to do this. So we do this much more often than any other project I'm aware of. And the only reason I would recommend against running current is if you think that you want to add a new package later on.
Okay.
Well,
Because
actually,
binaries
Well,
change.
if you
that's
can
fine.
easily reboot, this
If you
is
can
not even a
easily
reason.
reboot and easily upgrade, then it's fine.
Well, there are many scenarios where it doesn't make sense to run a release, and the release is basically every 6 months we have it, and then there are some maybe security fixes when they show up for the release without changing any of the configuration or semantics if it's for a release.
Or APIs.
APIs, so release is supposed to be stable, but we don't keep many concurrent whatever branches. We just have this linear, and then every 6 months there's a cut. And many companies, for example, when they run OpenBSD, they kind of want to run it, and then they update like twice a year, or some just once a year. That's usually also okay if they follow the security fixes. So, but most developers actually run in current where they can, but I do also run machines based on releases, or our products are following the releases. Yeah.
And all of us running the same current, basically, well, off by a couple of hours or days,
Yes.
but from the same branch, as in we don't really do much branches. If you have all these branches, you have a fragmentation of the development community. So basically everybody runs the branch he's working on. At some point you merge the branches into a release and figure out, oh, wait a second, they don't work together. This cannot happen to us.
Yeah.
Okay, cool. And so, like, what kind of cool things have you done with, let's say, multiple parts? Like, one thing like you know, with BGBD and PF, is there any cool stuff that you've done, like integrating like the various different services to do also?
Never.
You've never?
So
this is now a surprise.
I can very see where you're going with this, and this is a very funny thing. I kind of created this. I created this service that I call BGP Spamd, and I'm using that to distribute whitelists and blacklists that are used for anti-spam use. And I'm distributing this with BGP. And as I was so I created it and I'm running it. And as I was giving a presentation, I was writing materials for a presentation about it when I was going to announce it. And I discovered that the features I was using was written 10 years before. And even says in the commit message, this exact thing that I created. But nobody else had done it. So BGP has this nice ability to, when it receives a route from a neighbor, it can, based on any of the filter selection mechanisms, add it to a table in PF, and then PF can use all the IPs in that table to do any of the filtering actions, block, redirect, etc.
So you can kind of mark different threats with different communities, and then have the table in PF actually have different actions for each of those
Correct.
threats.
Like a very easy thing to do is like, oh, okay, we're getting attacked from this, so let's redirect all that traffic to the IDS for further inspection. Or we're getting like a slow denial of service, so you send it to your protection mechanism. You can identify any sort of your neighbors with this. Oh, this neighbors, we know they have problems above a certain bandwidth, so let's do traffic shaping there and things of that nature.
Okay.
There's a couple of cool hacks possible and actually being used, and one I really like is using the passive OS fingerprinting in PF to do redirections. So if you get a connection to port 25, your mail server, from a Windows machine, the chance of that being spam is like a gazillion times higher than any other OS, because most mail servers, the internet-facing ones at least, don't run Windows. However, all the Windows machines at home that get taken over by the latest swarm or whatnot, trying to send spam, are Windows. So redirecting connections to your mail servers coming from a Windows host to an instance of your mail system doing much more aggressive spam checking really makes sense.
Cool. So you can actually really adapt and tailor the response to any threat. And so the OS fingerprinting, can you just give a brief outline how it works and what you do?
Well, basically, you look at the initial SYN packet, and based on initial values, it chooses for Windows size. As is given, what else?
There's a whole bunch of, it's all of the various options in
the little
SYN.
bits in the packet. They vary a little bit between operating systems, and they vary enough that just by looking at that, you can make a, let's call it an educated guess, but it's a very good one, what operating system that actually is.
Sure.
I once filtered out a pretty big DDoS attack by throwing all packets coming from machines claiming to be Windows XP SP1. At that time, this was already ancient and people weren't, well, it was not a common use anymore, well, defined common.
Yeah.
But it wasn't the
norm
OS anymore. It wasn't the norm anymore, yes.
Yeah.
So filtering out all packets coming from Windows XP SP1 from a certain port, because the attacker always used the same source port, to the attacked systems, just throwing those away. This did affect a couple of legit connections, I'm pretty sure about this, but the number was very low. And being able to filter out the entire attack, like leaving all the others unaffected, very worthwhile. Spectacular results if you want so.
No, that's pretty cool. And like, one other thing that I didn't know existed, and I like to talk, is the optimizer in PF. So can you?
Yeah.
Because that sounds.
Yeah.
So let's say I create 200 rules, dump it into the PF config.
That's also a bit I really like. Basically, when you configure PF, stop thinking about performance impact. The optimizer does the job for you.
Okay.
So you write the rule set in the way that it is best maintainable and readable and easiest for you to work with. don't worry about the performance impact, the optimizer keeps care of that. That might not reach the perfection level, but well, you're using what, 5%, big deal.
Yeah. Okay, so, and can you give me some of the tricks that you're actually doing with the optimizer? Like what's kind of cool to piece the resistance, even though you're not French?
The probably most effective optimization it does is, it's very common to have a number of rules that only differ in the target IP address, or source IP address, but only differ in the IP address. So the optimizer will take those, let's say 20 rules, convert it into one rule that works based on a table. So it automatically creates a table where it stuffs all the IP addresses in. The optimizer will also reorder rules, where the reordering doesn't change the meaning at all, but allows another optimization called skip steps, where it basically jumps over rules that cannot match. Like a rule has a marker, this rule doesn't match because of the interface, so pass in on EM0. You get a packet that is not on EM0. The next 100 rules also all refer to EM0. So we know that these cannot match because EM0 has not matched on this rule. So this rule will say the next that can possibly match, if it did not match because of the interface, is rule number 101.
Okay.
And the optimizer will reorder rules so that this optimization again becomes more efficient, more effective.
So like if you write pass in, pass out, pass in, pass out, pass in, pass out, it'll reorder them so it's pass in, pass in, pass in, pass out, pass out, pass out.
I get you.
And it'll just skip all of the pass in for the outbound flowing traffic.
Yeah.
Okay. Cool. All right, guys. Is there anything else you want to say? Like, is there any OpenBSD? How can people support OpenBSD? Because it's not commercial. It's like it's more like the approach. I bought into the approach that you've used, and in fairness, I've used it. It's had a very good effect for us. So it's like, well, how can users help you guys help the user base in terms of like continue creating code and stuff like that?
Of course, I mean, obvious part is
Give us money.
Give us money, donations. There's an OpenBSD Foundation for large donations, and there are various other ways. You find it on the webpage and so on. Actually, important part is like among the donations we got, and last year was surprisingly good, and security is a topic that goes up, and OpenBSD seems to have a good time right now. But the largest part of the donations were like small donations, the sum of them by our users. So we have a few large ones by corporations that they do a chunk of money here because we use OpenSSH, it's an OpenBSD project, so they donate something. But then they were like outnumbered by the small donations.
Yeah.
But that alone is not everything, because we live from the fact that people are using it, give us good feedback, bad feedback we don't need, right? But,
truthful feedback is always welcome.
But this is
Constructive feedback.
Constructive feedback.
It's a good point. Run current, update often, like run our snapshots, update often, and tell us when things stop working or break, or there's new features, test them, tell us when they don't work as expected. When you see a man page being wrong, tell us. If you're a bit advanced, even send us a diff.
Okay.
Right? So
Diffs are not required, but they're absolutely welcome.
And what I actually like as well is like how when people tell me, give me feedback, well, I'm using your software in that setup, and it works, and I mean, I do have my own use cases, but sometimes it's overwhelming what setups are using this piece of software, and you see, oh wow, this huge thing is running on the software and it works, and the user is happy, and when you get feedback, I mean, Tom, you gave me feedback, you're using some of our stuff, and like, oh, that's great, right? So this is something that is just a story to hear, but it encourages to drive on, because we're giving away stuff for free for a long time. And so knowing these success stories or this user feedback, this is just
good motivation.
Good motivation.
So especially if you're using our stuff for let's say large scale or in unusual ways, let us know. We want to know about this.
And like, would you like some sort of like kind of like a few just kind of rough diagrams just to kind of paint a picture like case studies, or is that?
Doesn't have to be that way.
No.
Just drop me a line or
Yeah.
if it's something
Something casual is very nice. I mean, a case study could be good to show other users. You know, you can use that for your own advertisements. Wink, wink. But it makes us look good, and we really like hearing about this.
To be quite honest, for me, and I suspect it's the same for most other developers, a short, concise email to the point is worth much more than a lengthy paper.
Yeah.
Yes.
Yeah,
Yes.
and it'll reach a lot more people in terms of if you could, like a testimonial, like if it ever gets on the site or something. But I suppose one of the things I was going to ask you is if you're using OpenBSD as a desktop, which I know you all are,
Yep.
and I've installed it recently because I was using it more on headless systems and just routing and networking. And then I went, okay, let's try and see what the fuss is about. And so I was using it. So I was using XFCE on OpenBSD. That's what I was using because the default window manager is older. That's the
Less maintained than it should be. Let's just say.
Which one do you call the default one?
I'm not.
FEWM.
Well, that's what I'm using every day.
You're using
Largely because I'm an old fart and can't get used to new things anymore, apparently. But
Well, no, it's functional. It works.
largely, yeah.
But
I mean,
it's. Can I say it's not sexy?
Absolutely.
So,
Now
It
that's just
depends on your.
that is just simply the
on
basic.
your orientation, I really like.
I've seen people make it sexy. The configuration allows you to basically control every single pixel on the screen. So if you want, you can make it sexy. But I don't know how. I just know it's possible, and I don't care. Foremost, the desktop, yes, but even more so on laptops. When I travel and I have work to do, and I don't want to fiddle with the laptop or the operating system. It has to work. And there we come back to, I can depend on OpenBSD. It will not surprise me. It will just work. I don't have time to fiddle with Windows or macOS or Linux. And I don't want to spend the
Pity
time.
the dual booters. That's all I'm going to say. Pity.
So like I've been using OpenBSD as my primary desktop since approximately 2001, and for quite a long time. And I started off as a porter doing games and doing like graphical games. It has not been the fastest, but it's been fast enough. Easily fast enough. And like right now, I can on a basic laptop with Intel graphics, I can watch 1080p videos on YouTube, and I can stream them, and it's totally fine.
Okay.
And like the browsers are like it's modern Chrome, it's modern Firefox. All the usual things work. It's like I don't notice any incompatibility with things.
And like when it does all the mitigations that you talk about, like writer execute, the randomization, the stack protections, all that, that's all in there, all.
Of course, the OS level ones, yes, stack protector, memory protections, library things, etc. Yes, that's all built in. If it's an application-specific design, like Chrome does their own privilege separation tool, so it has more protections than OpenBSD, but it is not written by us, so it's not up to our own standards.
Okay, cool.
And the browser easily is the main attack surface today. And looking out of the window, there's a taxi coming, which would be ours.
Cool.
It's ours, yeah.
Because we have to fly out.
One last thing, just before we go.
One more thing.
VMM, there's a possibility that in the future you will be able to virtualize Firefox in a container. Thanks very much.
That's what we are thinking about, yeah.
High five, that's awesome. All right, lads, thanks very much. And
Bye.
bye. Cheers for that.
I hope.